Good morning, Rip2. How are you? Today we'll talk about the second type of motion in our curriculum, which is called wave motion. And in this lesson, we'll talk about four main points. The first point, the role of waves in transferring energy. Number two, the concept of wave motion. The third point, types of waves. And the last one, some concepts related to the wave motion and their properties. Let's start firstly the meaning of wave. The wave is a disturbance that propagates and transfers energy in the direction of propagation. And we have an experiment. This experiment very important to identify and knowing the meaning of wave motion. Okay, so if you bring tiny fork like this, glass tube like this, and candle like this in another opening, okay, and we had the tuning fork and put incense between the tuning fork and the glass tube. Okay, after hitting the arms of tuning fork, you will observe the flame of candle vibrates. Okay, so the sound waves have transferred energy from the vibrating point, which is the tuning fork, to the candle flame. Okay, and the vapor of burning incense doesn't enter the glass tube. So you can conclude that the molecules of air don't move from its position, but it vibrates to transfer the energy from the vibrating position to another position in the same direction. So the concept of wave motion is a movement resulting from the vibration of the medium particles at a certain moment in specific direction. Okay, and the direction of wave propagation is called line of wave propagation. Okay, but we have many types of waves and we can divide them into four main types in this lesson according to two main factors. The first factor is the direction of propagation of medium particles relative to the direction of wave propagation. And we can classify the types of waves according to this factor into two main types. The first type is called transverse waves, and the second one is called what? Longitudinal waves. Transverse wave like this, and longitudinal waves like this. If we concentrate in this figure, we will find that the direction of medium particles is perpendicular to the direction of wave propagation, and this is a property or the main character of transverse waves. The second type, longitudinal waves like this, the medium particles and or the vibration of medium particles in the same direction of wave propagation. So this is called longitudinal waves. The second factor helps us to divide the types of waves into another two types: ability to propagate and transfer energy through space, or need a medium to propagate, like mechanical waves and electromagnetic waves. Mechanical waves need a medium to propagate, but electromagnetic waves don't need a medium to propagate. Okay, and the mechanical waves may be transverse waves like this or longitudinal waves like this. Okay, but electromagnetic waves, all of electromagnetic waves are transverse waves. Okay, let's study the first two types. The first one is called transverse waves, and the transverse waves is the disturbance which causes the particles of the medium to vibrate perpendicular to the direction of wave propagation. But longitudinal, what it is meant by longitudinal, it is disturbance that causes the particles of the medium to vibrate along or in the same direction of the wave propagation. Okay, so transverse wave consists of or composed of two concepts. The first concept is called crests, and the second one is called troughs, like in this figure. Okay, the highest point like this, away from the origin position or away from the vibration of medium particles, is called crest, and the lowest point is called trough. Okay, but in longitudinal wave consists of compressions and rarefactions. Compressions means what? As we see in this figure, compression is a medium in which the density of medium particles is more, okay, but rarefaction, it is a area in which the density of medium particles is low. So each crest in transverse wave equal compression in the longitudinal wave. Each trough in the transverse wave equal the rarefaction in longitudinal waves. And we have an important life application of waves, which is called jacuzzi. And jacuzzi is a tube where water moves in circular waves, okay, and it's used to treat sprains and cramps when we use hot water or nervous tensions if it fills with cold water. Okay, now let's revise on this part. The first question, write the scientific term. The disturbance that propagates and transfer energy in the direction of propagation. Excellent. It's called waves. The movement resulting from the vibration of the medium particles at a certain moment in a specific direction. This is called wave motion. The highest point in the transverse wave. Excellent. It is crest. And the lowest point in the transverse waves is trough. Okay, let's complete our lesson. The second two types are called mechanical waves and electromagnetic waves. And this classification depends on the ability of the wave to propagate through medium. So the first type, which is called mechanical, they are waves which need a medium to propagate and to transfer energy. Okay, but electromagnetic, they don't need a medium to propagate through, as they can propagate through space. Okay, and the mechanical waves may be longitudinal waves or transverse wave. Longitudinal waves like sound wave, but transverse wave like water wave, which consists of crests and troughs. The second type, electromagnetic waves, and all of them, or all of electromagnetic waves, are transverse waves, like light wave, microwaves, infrared waves, or X-rays, ultraviolet rays, or radio waves. Okay, so mechanical energy and electromagnetic energy was propagates in different materials. However, the velocity of mechanical waves is much slower than that of electromagnetic waves. So electromagnetic waves can propagate through space with a great velocity, which is 3 by 10 power 8 meter per second. And this speed is the speed of light through air or through space. The last point in this session, concepts relative to the wave motion. First concept is called wavelength, and the second one amplitude, the third one velocity, and the last one is called frequency. But the first one, which is called wavelength, and its symbol is lambda like this. Wavelength of longitudinal wave, it is the distance between the centers of two consecutive compressions or rarefactions. Okay, but wavelengths and transverse waves, which composed of crests and troughs, it is the distance between the centers of two successive crests or troughs. So the meaning of wavelengths differ from transverse wave or longitudinal wave. Okay, but in the both types, the measuring unit of wavelengths is meter or centimeter. Okay, and the fraction of meters like millimeter, micrometer, or nanometer. Okay, the second concept, amplitude, and as we studied before, amplitude in oscillatory motion, if you remember, amplitude in wave motion is the maximum displacement achieved by the particles of the medium away from their point of rest or their rest point. The second or the third concept is called the wave velocity. Okay, this is the distance covered by the wave in 1 second. Distance covered by the wave in 1 second. Okay, so velocity equal distance covered by the wave in meter divide time in second, and the measuring unit of the wave velocity is meter per second, and the velocity of the sound is constant for the medium, so the sound travels with different velocities in different media as we see now. Okay, the sound speed in air is 340 meter per second, but in water 1500 meter per second, but in wood or in solid 1850 meter per second. And this figure help us to identify the difference between the speed of sound through different materials. Okay, the last concept in our lesson, frequency. Frequency is the number of complete waves covered in 1 second. As we studied in oscillatory motion, periodic time is reciprocal of frequency, so it's equal 1 over frequency. Okay, and if we collect all of these concepts in one law, this law will be called the law of wave propagation. And the law of wave propagation, it represents the relation between the wave velocity, frequency, and wavelength. So law of wave propagation is what? Is the wave velocity equal frequency, which measured by hertz, by wavelength, which measured by meter or fraction of meter. Okay, solve this problem. Calculate the wavelength in meter for a visible light wave of frequency equal 6 by 10 power 8 megahertz, not hertz. So we will convert this measuring unit from megahertz to hertz firstly. The second given speed of light is 3 by 10 power 8 meter per second. Firstly, frequency equal what? Equal 6 by 10 power 8 by 10 power 6 to change from megahertz to hertz. So the frequency by hertz unit is 6 by 10 power 14. Wavelength equal what? From law of wave propagation, wavelength equal velocity divided frequency equal 3 by 10 power 8 divided 6 by 10 power 14 equal half by 10 power negative 6 meter. This is the wave length. Now we have finished our session. Thank you for your listening and goodbye.